So everyone, I think it's time to start today's webinar related to real-time simulation with Creo Simulation Live. So a warm welcome. My name is Johan Edelgard and I'm head of marketing at PDS Vision. The topic of simulation lies close to my heart. In a previous role I held, simulation was a cornerstone of the solution I was responsible for. And it was a topic that I discussed with many organizations around the globe over the years. But today you will not hear me talk about it. Instead, you will be fortunate enough to listen to two people with great knowledge and great insight related to simulation in context of real time. But before I'm handing it over to Eric and Graham, two amazing resources from PTC that we at PDS Vision have had the fortune to work with for some time now, I'll just say a few quick words about the platform we're at and also a few words about PDS Vision as an organization. That is mainly for those on the call that does not work or engage with us on a regular basis today. So a few words about PDS Vision. As you are very familiar with and most likely are living in the middle of, products are becoming more and more complex. Combined with that, many organizations are sitting in system and process landscapes that many times do lack connections and synergies. In addition to this, change is something organizations will have to manage through all stages of development and the life cycle. So to develop a high quality, high performing product at the right time at the low cost becomes quite challenging. But this is where we at PDS Vision plays a part. We work with organizations to break down this complexity in order to make it a competitive advantage instead. We work with organizations to create homogeneous processes and systems. Today, we work with several hundreds of organizations to increase the efficiency of the engineers and the organizations as a whole. So we work across the entire life cycle, but to use the terms used in the industry today, the domains and areas are CAD, PLM, SLM aftermarket, IoT, and then mainly related to the concept of smart connected products, application lifecycle management, and mainly around requirements management. We do come in with expertise about the supporting technology, which we also consider to be the absolute strongest technology on the market today. If you take the PTC technology as an example, it is by our customers and analysts validated over and over again that they are the leader and they are helping users of their technology to create a competitive advantage. What we will see today with Creo Simulation Live is an example of this and how PTC is investing to secure true value for the ones using the software. And at PDS Vision, we combine this with know-how connected and related to processes, methods, and best practices. It makes us perfectly situated to help organizations manage the challenges they face today. In our engagement, we of course also have different hats on depending on the engagement and the situation, but I will not go into any details of this today. Instead, I will hand this over to the masters of real-time simulation, Graham and Eric. Please take it away.
Thanks very much, Johan. It's Graham Cox here. Hello, everybody. Thanks for joining the webinar. We've got myself from PTC and a couple of my colleagues I just wanted to introduce as well on the line. We also have my colleague from our Centre of Excellence in Barcelona, Spain, Eric Horowski, and our colleague Harry Lee is actually not here this week. He's actually on holiday, but Harry has just joined our team in Barcelona for high velocity sales, and he'll be supporting the Nordics countries. And he's a good contact within PTC, a good first point of contact if you have any questions coming into PTC on any subject. So as we around the world to understand their goals and objectives, we find there's a lot of commonality in what people are. There's a desire to innovate and to improve products while simultaneously understanding how those products are going to perform in real-world conditions. Companies want to gain market share by bringing products to market more rapidly, and hence there's a need to reduce the design cycle times in order to achieve this. There's always pressure to reduce costs, for example, by building fewer physical prototypes and by achieving first-time quality with the product as it goes into the market. And also by reducing costs due to the warranty and liability issues throughout the product's life. Now, I'm sure this picture of a typical product development cycle is familiar to many of you, and simulation tools and computer-aided engineering have been used as part of this process for many years to address the challenges that I mentioned on the previous slide. However, simulation tools today are largely used as they're shown here as part of a final validation process after the design is practically complete, by which time many costs, for example, tooling costs, have already been committed, and late changes as a result of that simulation either have to be ignored because it's too late, with the resulting quality problems in manufacturing and through life performance, or you have to go back to the beginning and start all over again, and the cost that you've already spent may be lost, and you're increasing the overall cost of the process. So the easy way to address this, or it would seem to be easy, is to just to run the simulation earlier in the design cycle. But often engineers don't feel that they have the right expertise or background to run those simulations and to be confident in the results that they're seeing. So they often need to rely on consulting an expert within the organization. Now, that expert may typically be very busy and have a big backlog of other work to complete. And hence, again, there's delay introduced into the process. So another problem with running design simulations early is that the first task is often to have to simplify the design geometry in order for the simulation to run successfully. And again, this causes a lot of delay. And finally, design itself is an iterative process where many different approaches to product optimization are tried out. So to run through those multiple iterations, running a simulation every time, each one could take many hours, and this is highly inefficient, it's disruptive, and typically that means it simply doesn't get done. So to address these challenges in 2018, last year, PTC announced a strategic global partnership with ANSYS, the market leader in the CAE and analysis market space. And by bringing our two organizations together, market leaders in our respective fields, we're able to remove the barriers that I've described. Effectively, what we've done, and we're going to show on the demonstration today, is to take the best-in-class analysis tools within ANSYS and integrate that directly into the Creo user environment. And the first product we have in this partnership is called Creo Simulation Live. And this gives the engineers fast, easy-to-use simulation. It's fully integrated into the Creo modeling environment and the menus. And when the changes are made in Creo, the user gets real-time feedback. The big change in this capability is the speed of the response, the instantaneous nature of simulation. Many of you who may have used simulation tools already, and I can see on the polls that several people have said that they already use the Creo Simulate tool within Creo. Although Creo Simulate, this is a strong tool, but it does have the sort of traditional approach of having to run geometry simplification, having to run meshing and optimize the mesh, and then wait for the result to solve. What Creo Simulation Live does is take all of that away. The user doesn't see any meshing at all. That's all run in the background by the software algorithm. The geometry simplification is not necessary. That's done by the algorithm, and the results are instantaneous based on the solution using the parallel processing on the graphical processor unit on the desktop. So the result of all this is that the engineers can get instantaneous feedback on the design changes that they're making. They can see if what they're doing is taking them in the right direction or the wrong direction, and they can run multiple iterations more quickly and design with greater confidence. Creo Simulation Live is one of those things I think it's better seen rather than talked about. So at that point, I'm going to hand over to my colleague, Eric, who's going to give a bit more technical detail on the solution, and then we'll run into the demonstration. Eric, it's over to you.
All right. Thank you for that introduction, Graham. And so to sum up what Graham was just talking about, being able to understand and get this quick insight much earlier will save you a lot of pain down the line. Someone explained this to me in a really neat little package where Creo Simulation Live is like the spell check to design. You know, you get that instantaneous feedback whenever you're writing an email and maybe you fat finger something and misspell a word or forget a letter. You get that little red line that shows you, hey, you know, Eric, by the way, you misspelled this. Maybe you want to check that out, or maybe your grammar's not quite right. It's the same exact principle here, because what we're doing is we're allowing you to get that instant feedback and say, Eric, taking a look at this, these stresses aren't looking too good, or hey, you can get this quick glance. Maybe that rib's not in the right place because it's not doing what you want to. And we all know making these design changes, we like to leverage our previous engineering knowledge and our expertise, but sometimes there are things that don't follow the exact norm. And this is where it can very much help you. Because as Graham was mentioning, Creo Simulation Live is a very powerful linear solver. It runs through the algorithm and it gets you these answers very quickly because it automatically meshes and converges. And you can do structural, thermal, or modal analysis in order to understand how your assembly is working. And this is all within Creo. Now, if I take a look at the survey results here, a majority of you are using Creo Simulate. We also have, a lot of designers. And what's interesting is that almost all of you are currently conducting early simulations in the design phase, or you feel that there is a need for it. So you can run this in your environment and you can take a look and understand what's going on. So in this example, what we see is we're getting that quick feedback. And when Graham said it was fast before, it's really fast. It's more on the scale of seconds or a minute to get your results from it rather than, hours or kind of the time frames that you'd be expecting from a typical analysis tool. So the solver is running continuously as you're going through design. When this first came out, it was really interesting because they were showing it at LiveWorks, which is PTC's large event. Hope some of you will be able to attend. That's coming up very soon, if not this week. And it was interesting because engineers loved it. It was almost like a game because they made their changes and they saw instantly, oh, there's a hot spot there. Let's go ahead and address that. It takes out this guesswork and the headache of jumping through multiple hoops back and forth to run the analysis. Okay, well, that didn't work. Let's go back and change it, or having to throw it over the fence to your analyst to go through and run it. And like Graham said, if this is too inconvenient, it just won't get done. And so you can very easily see the results of this. Now, I've seen a demonstration. It's actually something very similar to this. This part here, this rib, what they showed is exactly what we're trying to avoid, is missing something that would seem like an obvious answer, but it actually isn't. Because in the scenario, what they did is you see, okay, there's a stress on this corner here. It's a bit high. Let's go ahead and address that. And what they did is they did what every engineer would do and say, okay, let's increase the radius on this so we can spread out that stress over a wider area so it's not so focused. And in doing so, it actually increased the stress on this part and in this area due to just the unique way that all the geometry came together. And that's why we're talking about this being a spell checker kind of application, because you get that instant feedback and we can see, like Graham said, make sure we're going in the right direction. If we change this and then suddenly it all comes up red, we go, whoa, okay, that's the wrong way. Let's go ahead and make sure we can try something else. And this is all done early in the design phase while we're still playing around with it, changing things, and we still have time to use on innovation and trying new designs before it becomes too late. Like Graham said, you've already spun up the tooling, you've already invested a lot of time where you're basically you've entrenched yourself down this path and you don't have enough time to start turning. And so you can dynamically query this information. Like he said, it's using the power of your graphics card to parallel process this and get instantaneous results and to highlight the important pieces of what you're seeing. So without any further ado, we can get into the demonstration and actually what it looks like to use. And let's see, so as we go through here, we are in Creo. And this is a ski tip, but it could just as easily be any structural piece of one of your designs. This could be a support structure. This could be an A-frame in an automobile. And what we're doing is we're also using new design techniques available in the market. So maybe 3D printing or manufacturing with new shapes and these new support structures. So this is simply a tab in Creo. You see it up there, live simulation. And we'll go through with it just like you'd expect to go through any other sort of simulation. So first we're going to start with boundary conditions. Very easy to do, and since most of you are familiar with Creo Simulate, this will be a very familiar interface for you. So, okay, sure, we're looking at deformation. We want to make sure that it's not flexing too much, and we want to make sure that it's not being overstressed. So that's how it looks. That's the mode in which it's flexing in. Now let's take a look at something else. Let's look at the stress. So we can see here, okay, it's actually doing pretty well. Now, of course, we don't just use simulation to say, okay, will it break? We also want to know, hey, are we wasting material? Are we overbuilding this? So now we can help to use simulation early so that it's not just, okay, let's get the first answer we can that works. We're going to make sure that we're getting the right answer. So sure, stress has increased a bit, and we can determine based on what materials we're using if that is an issue or if we're still in the safe bounds. And note, let's see, we've gone through 2 simulations already in the span of 60 seconds. This is something that just wasn't possible before. And then we'll even go through another one. Maybe we want to change how it flexes and fill in some of these honeycombs in this area. So let's go through and adjust that now and take a look and see how that affects our overall design. And note, just like this, okay, we've made this change, boom, it has already converged and given us the results of our analysis. That's how fast it is. So the value behind all of this is the speed and the ease in which you can make these changes and then see the results. So as soon as we regenerate again, bam, we get the updated results. So this case here, this is a structural example. We're taking a look at if it's flexing. The next one we're going to go through is a modal analysis, because as we all know, something very important for a design is to make sure we understand the relative stiffness and natural frequency of our parts. And this is an example of taking the intake of the engine and saying, well, right now it's made of aluminum. Can we do this in plastic? Lighter weight and a more cost-effective material. Now, I'm not saying cheaper here. I'm saying more cost-effective because it will cost less, but we need to make sure that it still fulfills the design requirements. Okay, so we have our part. And then this is with aluminum. We're going to compare our results here and then just, again, set up the boundary conditions on where it's fixed. And just like that, we now have our results. So if you think about the last demonstration we went through, that was a few minutes and we went through what, 5 different simulations? This is what we're talking about when you can try new things and really have it work for you. And what's really nice is that with Creo, this is also able to be used with DEX or design exploration. So this is now a force multiplier for you when dealing with the early design exploration, because you can try out new things, get the results, and then have the entire breadcrumb trail that you went through on that design to see where you ended up and how you got there. Okay, so we see that, yep, there is the frequency there. And maybe we want to change that a bit. And then in this case, let's start adding some support structures. So we'll put a rib in there, since that is the main point that is flexing for us, and that's where we got that feedback from Creo Simulate Live, and it lets us know, hey, Eric, this would be a good focal area. All right, great. So we can go ahead and then drop that in. And I see that in the polls, for those of you who said, yes, we do have a need for this, this is exactly what you can start doing with it. So you can see where you need to make some changes early on without having to either A, wait for the simulation to complete, or B, without having to send it over to the simulation team or go through and do any sort of additional simplification. So we can see we've already improved the performance of our part just from that feedback. And These are huge time gains and savings here. And I also know, this is actually true, by the way, whenever you're focused in on a task and really in the zone, that is a magical place to be in terms of productivity, efficiency, and getting things done. If you get taken out of that kind of Zen-like state, it will take you at least 21 minutes to get back to that point of straight focus. And anytime you're having to run a simulation that takes you about 10 minutes, you have to go back, get a coffee, wait around, that is you losing out on that focus, and then you'll have to spend another 20 minutes to get back to that point. So what we're talking about here is not just, okay, it saved me 60 seconds. Something like this, now it can start adding up to a half hour of focus and time lost in being productive for every simulation you run. In the past couple minutes, we ran through about 9 simulations. That's 4.5 hours. That was just half of your day right there in productivity. Now, of course, results vary depending on user and so on, but here is some hard numbers to go forward with. This is running through a modal analysis on a crankshaft, and we're comparing the results between Creo Simulation Live and Creo Simulate, which behaves like your typical simulation tool. Now, the results, okay, about less than a 2% difference. The time it took, 3 seconds versus 3 minutes. 60x times the time saved there using Creo Simulation Live. Similar story, we're looking at the torque load here, about the stress and displacement. Simulation Live versus Simulate, percent difference, 6%. The stress, 12% difference. So something else to understand is that Creo Simulation Live and Creo Simulate, they aren't competing with one another. They are complementary, because early on in the design process, time is what you need. So you can try new things, you can do new ideas. This 6 to 12% difference, that's negligible because it gives you the direction to go in. We're not trying to find the final results at the early design point. We're trying to understand what is the best version going forward. Now, when you start getting towards the end of the design stage, now, like Graham said, this is where you want accuracy. So we've already gone through and filtered through a lot of our different attempts, and then we're really just polishing it up at the end. So that's where you do the high fidelity simulation, and that's where you want Creo Simulate. So you now have another tool in your bag to go forward with in order to improve your designs and your quality. So same thing here, less than a 2% difference and a huge savings in time. And then don't just take our word for it. We already have customers who have seen this and used it and really like it. For example, Stephen here, he loved it, and it helped him to design new parts for SQ Lab, and they do ergonomic sports equipment. And he was able to do a stress analysis himself when he typically wouldn't. He'd usually leave that to the analysts, but now since it's so user-friendly and easy to use, he makes his design change, he checks and sees if it's going in the right way, if it's good, and then he can move on from there to designing the next big part. So why go with Creo Simulation Live? Why is this important? Why are we all here together today to understand what this can do for you? it gives you a deeper understanding of how your product is performing much earlier. So we're not just having to rely on educated guesses or past experience, because as we start designing new things, take a look at the ski tip, for example. We're doing honeycomb patterns. We're doing 3D structure support materials. That's not something that tradition can really help us with. So at least not able to understand that quickly. So because it gives you that deeper insight, you can ramp up, have shorter development cycles, or do more development cycles and new iterations to have a better product. So better first-time quality while saving you time and money there. So that's the reasonable cost part, is just by having this additional insight, you are now gaining an edge over the competition, because you'll have reduced warranty liability because you have better quality. And by having simulation-driven design throughout the entire development process, you can make sure that the final design you have at the end will be polished and honed to your exact needs. You won't have to be stuck with going with a less quality product just because you ran out of runway. All right, so in that case here, that is the overview of Creo Simulation Live. Now what we can do is we can jump over and see if there are any questions that we have, and we can help try to answer them here today.
Thank you very much, Eric, and thank you, Graham. So for the people in the audience here, as Eric just said, this was an overview of Creo Simulation Live. But with that, Eric and Graham, I will jump into the questions here directly. I have a number of questions that relates to which release of Creo are supported for Creo Simulation Live. There are 3 or 4 questions on that, actually.
So on that one, Johan, Creo Simulation Live is supported now on Creo Release 4, Maintenance Release 90, M090. It's also supported on Creo 5.0.4, and on Creo 6 has just been released just in the last week. So that's Creo Simulation Live supported on 6.0.1. So it's supported on Creo 4, 5, and 6, those different releases. But we can send out that information when we, if anybody wants full details on that.
Absolutely, that's perfect, Graham. So people with that question, if you need more details, please do get in contact with us, and we will make sure that you get full disclosure on what is considered to be the ramp-up time for someone that want to start Simulate. I assume that means Simulate with Creo Simulation Live.
The whole idea of it, as Eric showed in the demonstration, it's very easy to use, very familiar interface to anybody who's already a Creo user. There is a self-study education course available on the PTC University now, if anybody's familiar with that. It's sort of self-study web-based education. So 2 hours on that self-study education course, we believe that would give anybody who's already an engineer using Creo the right right knowledge to be able to use Creo Simulation Live productively. We have some customers like the SQ Lab reference that Eric mentioned. They got up to speed. They downloaded the software. They started using it pretty much immediately. I think particularly already familiar with Creo Simulate. In applying the loads and constraints there, it's exactly the same mode of operation. And in fact, I think Eric mentioned it in the talk over that he did, the those loads and constraints are interchangeable between Creo Simulation Live and Creo Simulate. So in summary, it's a very easy system to be able to pick up. I don't know, Eric, if you want to comment on that.
I think it's all been pretty much said. It was made so that it is a familiar interface, and it works the way you'd expect simulation to. So it's made so it's a low barrier of entry for you.
Okay, perfect, Eric. Thanks, Graham. So that leads me to next one, and I think to a certain extent you covered some of this, Graham, initially, but how does Creo Simulation Live compare to the existing PTC solutions? I assume that means Creo Simulation.
Yeah, I think. Yeah, today, so we have Creo Simulate, Creo Advanced Simulate. We also have a computational fluid dynamics, a CFD solution in Creo Flow Analysis. So in terms of the positioning of it, we're not trying to displace or remove the need for those sort of high fidelity tools, but the idea is when you get to that point in the product development cycle and you use those high fidelity tools like Creo Simulate for product validation, you will already be at a point where you've got much better confidence in the design quality and the the simulation will be a good fit to the product design definition. So it's a complementary capability. Again, as Eric mentioned earlier, people use a lot now the term democratization of the simulation capability, and the idea there is it's to give everybody the ability to use this type of tool, right across the organization, rather than have those skills and capabilities concentrated in the specialist team of simulation specialists. Now, not trying to take anything away from that team, because what we're trying to do is take away the backlog of trivial work that team maybe doesn't want to be doing every day, but to concentrate more on the the more specialist stuff and more more sort of validation work that they should be doing anyway.
Perfect. Thank you, Graham. I have two more questions in the question tab here. So if there are more questions, please add them. But this next one, I'll take them in this order. The next one relates to what you said, Graham, and I don't know how much you can say or how much you know about this, but the question is, are there any plans to include flow analysis in Creo Simulation Live in future releases?
The short answer to that is yes. As I mentioned earlier on, the partnership that PTC has forged with ANSYS last year, we are continuing to work with the ANSYS development team. The PTC development team is working quite closely with the ANSYS development team. Creo Simulation Live, as we have it today, is the first software release, but there will be further software releases coming, over the next 12 to 24 months. Two major things that will be coming, probably not in Creo 6, probably in the Creo 7 timeframe in 2020, and that would be the CFD, the flow analysis capability, and also the ability to run non-linear structural analysis. Again, as Eric said, today in the structural analysis, we run linear solutions. In the future release, probably around Creo 7, we will have non-linear capability as well. So yeah, short answer is yes, those capabilities will be coming in future releases.
Interesting. Yeah, that's great to know. So nothing that's in there now, but there are further plans for Creo Simulation Live. That's really good. So they're popping in more questions here. So I'll as long as you, Eric and Graham, have time, I will stick to this here. Sure. Next one is related to licensing. So how will the licensing work for Simulation Live? Can you say anything about that without, as I said, going into prices and things like that, Graham?
Yeah, for anybody who's familiar with Creo extensions, Creo Simulation Live is effectively just another extension license. So you need a Creo base package license, be that Creo Essentials or the new Design Essentials, Design Advanced. You need a base Creo license, but the Creo Simulation Live sits on top of that as an extension.
Perfect. Thank you very much. Next one is related to hardware requirements, I think.
That question, I can see that question also, Johan, from Robin. And yeah, maybe I'm not sure we mentioned this, but yeah, the GPU hardware that is required to run Creo Simulation Live needs to be an NVIDIA card. NVIDIA being one of the major suppliers of GPUs globally. And there is a whole list of Quadro cards that are supported, which again I can forward. I'm afraid I don't recognize that particular number of the Quadro card. There's two things I would say, however. One is the number of cores that you have on the GPU card will affect the performance in terms of the accuracy, the speed of the result that you get. And the amount of memory that you have on the GPU will affect the accuracy of the result. We have a customer here in the UK who purchased some Creo Simulation Live licenses in May. They ran a trial of it. They were quite concerned because they already had NVIDIA cards on all their Creo machines.
You there, Graham? Okay. As to that particular scenario, I was not involved in that engagement, so that's a story for Graham to tell. But yeah, the main key factors are the cores, so that's the speed, and then you also need a minimum amount of RAM in order to perform these types of analysis.
Okay, perfect. Thanks. So, Eric, I'll continue this with you, but one question is, can you reuse simulation live data with Creo Simulate?
By simulation live data within Simulate, I'm going to assume you mean kind of the boundary constraints and so on, and the answer is yes. So Graham mentioned before, you're actually, and I talked about in the demo, you're able to take those constraints and then apply them and bring them over.
Perfect.
I'm back, Johan. Can you hear me now?
Yes,
Yep.
we can hear you, Graham. We can hear you.
Yeah, sorry, guys. So yeah, just to finish off the short story I was telling about the customer using the NVIDIA Quadro cards, they were quite concerned that their cards were quite old and the memory would be insufficient. But in fact, when they started to use the software, they found that the results they were getting were perfectly adequate. They were happy. They didn't have to invest in new ones. But I will a Quadro card, the K2100M, and in fact, we have a whole list of supported Quadro cards as to what's supported, so we can send that out as well with the information, Johan. But as Eric said, I think another big consideration is the memory.
Okay, great. Thank you. So I actually think that was all the questions that we have received so far.
I can see one other question about which files are created when using Simulation Live.
There you have one more. Please go ahead.
The answer to that is that there's no additional files created. The data is stored within the Creo tree itself. And as Eric was mentioning, if you're running multiple simulations on a single geometry, you may try, different parameters of loads and constraints on the same geometry. They are all stored in separate separate branches of the tree within Creo. You do have an option to export an HTML file with the simulation results to people who maybe don't have Creo but want to see those results. But that's optional. You don't have to do that HTML export.
Great. So let me just double check again so we haven't missed anything in the chat or in the questions tab. No, it looks like all questions are answered.